Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder Ch.2 multiple choice question number from 42 to 44. The question is, a horizontal conveyor belt is running at a constant speed Vb is equal to 3 meter per second. A small disk enters the belt moving horizontally with a velocity V0 meter per second that is perpendicular to the velocity of the belt. Coefficient of friction between the disc and the belt is 0.5. So 42 is, what can you predict regarding the path of the disc? It is a parabola relative to the belt. It is a straight line relative to the belt. It is a parabola related to the ground. It is a straight line relative to the ground. So these four options, and we have to check which all are correct. This is in 42. 43 is saying what should be minimum width of the belt be so that the disc always remain on the belt, means it does not fall off from the belt. 44 is what is the minimum speed of the disc relative to the ground, that is about V0 during the entire process. Let us solve this question. This belt is moving with a velocity Vb in this direction, that is in the x direction relative to the ground. And the disc is entering onto the belt with a velocity V0 in the y direction, that is perpendicular to x axis relative to the ground. So what will be the disc velocity relative to the belt? So we can write, we know velocity of disc relative to the belt, VdV, is equal to velocity of disc relative to the ground minus velocity of belt relative to the ground. So if we flip x and y direction to bring it into this plane like this, so this is the belt velocity relative to the ground in the x direction, and this one is velocity of disc relative to the ground, that is v0 in y direction. So from this equation, vdg, vector vdg minus vbg, so we have vbg is in this direction, so minus vbg will be equal and opposite in this direction. So this is your minus vbg, and vdg is here. So the resultant velocity will be from the parallelogram will be in this direction. So that is velocity of disc relative to the belt. The disc is moving in this direction relative to the belt, means the friction force will be acting just opposite to this, to oppose this tendency of motion. So friction force will be in this direction. Let us say this angle as theta. So this angle will also be theta, that is corresponding angle. VDG, we know that it is V0. VBG, we know that it is VB into the direction of VB is in the x direction, so we can include I unit vector, and for VDG we can include the unit vector in the y direction, that is j. So if we put the value of V0 and VB, so our velocity of disk relative to B, means belt, will be 4j minus 3I, and its magnitude will be 4 square plus 3 squares whole thing under root. So that will be 25, so 25. So this VDB will be square root of 25 is 5 meter per second. This we will call it as number 1 equation. This friction force is acting exactly opposite to the velocity of the disk relative to the belt all the time. So we can say that relative to the belt, the disk is moving in a straight line. That will be one of your choices. Now if we want to find out the magnitude of friction force, so we can write Fr into Fr is equal to mu mg. Mu is the coefficient of friction, and mg will be the normal reaction on the disk because it is not going out of the disk. So weight is, the disk is being pulled downward by the gravitational force mg, so reaction force, that is normal reaction, will exactly be opposite and equal to it, so mu mg. So from here we can get the acceleration, because the force is in this direction, so acceleration of the disk will be in this direction. It is moving in this direction and acceleration is in this direction. So we can say, if you want to say, it is a deceleration. Now the component of this acceleration in the x direction will be ax cos theta so that will be 5 cos theta. But cos theta from this diagram we can get this very conveniently. This is b, b is 3, and this one is hypotenuse, so 5, so 3 by 5. So ax will be 3 meter per second square in the direction of x-axis. Similarly, we will calculate for ay. Ay will be sine theta. Ay will be in the y direction, ay sine theta. That is 5 sine theta. Sine theta, if we put the value of sine theta, we will be getting 4. But the acceleration in the y direction along the y-axis will be negative to the y-axis, negative to the direction of the y-axis. As we discussed already, because this disk relative to the belt is moving in this direction and the friction force is acting exactly opposite to it, so it will not change its direction. So we can say that velocity of the disk relative to the B belt will be in a straight line. So option B is matching with that. So option B will be one of the correct option. Now we will calculate for the velocity of disk relative to the ground. So R, if we select this direction as R and this direction as R perpendicular, so we can write R means distance traveled by the particle in the direction of R in time t as component of the velocity relative to the ground in this direction, that is V naught sine theta t minus half a t square. This acceleration is in this direction, so minus sine k. So we will be getting this much, 16 by 5t minus 5 to t square. Now, during this t time, what will be the distance covered in r perpendicular direction? So in r perpendicular direction, there is no acceleration. So we can write v naught cos theta into t. And that will be equal to, when we put v naught 4 and cos theta 3 by 5 into t. So this will be your 12 by 5t will be your r perpendicular in t time, the distance travel in r perpendicular direction in t time. Now if we put the value of t from here in equation 3, we will be getting 16 by 5 like this equation. If you calculate and simplify it, it will be 4 by 3 r perpendicular minus 5 by 2 into 5 by 12 square into r perpendicular square. So this is a quadratic equation. And quadratic equation, you know that it traces the parabola. So we can say that relative to the, we are calculating all these distances relative to the ground. So we can say that when we see, or when we are observing the disk from the ground, the disk will be moving in a parabolic path. So option C will also be correct. Now let us go for 43rd or 43 section. Question is saying disk should always remain on belt. So what does it mean? Disk is moving perpendicular to the belt, observing it from the ground. So the width of the belt should be such that it is just equal to the distance traveled by the disk when it comes to stop in that direction. It's perpendicular to the belt. So we can write this equation conveniently. Final velocity in that direction perpendicular to the belt when we are observing it from the ground will be 0. Initial velocity was v naught, so we can write v naught square minus 2 into ay into width of the belt. Ay we have already calculated earlier, so we can put that value and we will evaluate for w. So it will be coming 2 meter. So it means for the disk to be always on the belt without falling off out of it, the minimum width of the belt should be 2 meter. It can be more than that, but minimum should be 2 meter. So 43 option C will be correct. In 44 it is being asked, what is the minimum velocity that the disk will achieve with respect to the ground throughout its motion. So only in the direction of V naught sine theta, means in the direction of friction force, where the motion of the disk is reducing gradually because the force is acting in opposite direction. So this velocity will become zero, but in the perpendicular to it, that is in the r perpendicular direction, there is no acceleration or deceleration. So the disk will keep continuing with the v naught cos theta in this direction. So minimum velocity that the disk can achieve when v naught sine theta becomes zero. So v minimum will be only the v naught cos theta. We will put the value and calculate for v minimum. It will come as 2.4 meter per second. Option C is matching with it, so option C will be the correct option. So hopefully you understood the concept. In case of any problem in understanding anywhere, please do write in the comment. I will clarify that. And please subscribe the channel. Thank you.